Now we will watch something.
In 2000, this now experiment that was able to measure
How they catch the neutrinos.
electron neutrinos and also all the flavors of neutrinos, all the families of neutrinos, confirmed that the solution to the solar neutrino problem was that neutrinos change flavor. Neutrinos change type when they come from the sun to the earth.
You see, we told there is quantum coding, DNA coding, and computer 0 and 1s. The neutrino is changing also. It has code more complicated. The same
We
particle.
also say that they change flavor. We don't know why, but neutrinos
It's in the sun when two hydrogens fusion, a neutrino comes out from the sun.
and all particles come in three families. On the way from the sun,
On the way it's coming through the sun, it changes this kind of neutrino, this kind, it's changing. Why it's changing? It's a coding
to
system.
the earth, neutrinos that were produced in one family, electron neutrinos, change to the other families, mu or tau neutrinos. This is called
Why I'm telling there is coding system, it's changing. If they catch it, and when it started, what kind of it becomes the same kind. Because of this, I'm telling there is coding system.
neutrino oscillations or neutrino flavor conversion. Gray Davis experiment was only sensitive to electron neutrinos, and that's the reason why Gray Davis experiment was measuring less neutrinos than the predicted by geometrical calculations. The discovery derived by solving the solar neutrino problem is that neutrinos are massive. We don't know why neutrinos have different masses.
It has taken more than 40 years to find the right amount of neutrinos coming from the sun.
Okay, now we have told you there is coding system not in the light quantum, in the neutrinos also. If we claim that they are angels, they have minds more clever than us. Okay, we will see something here. The day they see angels, no tidings will be that day for the criminals. And the angel will say, prevented and inaccessible. When the resurrection day, God is telling, when the criminals, they will see the angels will tell, Hijran Mahjura, there is no paradise for you. This is something strange here. Now we don't see angels. When we are resurrected, we will see them. We will see the angels. Okay? It's telling like this. Now we don't see the neutrinos, but when we are resurrected, we will see them. Because neutrinos they are light also, they are made of light. We are not sensitive to that light now. But when we are resurrected, we will have that sensitivity. We will see that neutrino. We will see that.
I am the universe.
What is so special about the South Pole?
Now we will watch a video how they detect neutrinos.
The South Pole ice itself is the detector.
They use the whole South Pole as a detector. The ice, now we watch after iceberg.
Between 1.5 and 2.5 kilometers below the surface, groups of light sensors are in position to see the light produced by particles passing through the ice.
They put 2,000, 5,000 light sensors 2 kilometers under the South Pole just to detect one neutrino, two neutrino, small part they detected. They put about 1 kilometer. Why they make it in the South Pole, you will see.
5,160 of these light sensors.
5,000 light sensors.
Instrumenting a volume of 1 square kilometer.
At 1 kilometer.
High-energy neutrinos produce a zoo of charged particles when they interact with the ice. These are...
What's happening? billions of neutrinos at passing. They sit and wait. Rarely one neutrino hits an atom. Trillions, millions passing by from the Earth. By chance, one of them hits an atom and gives it a light. This light they call Cherenkov light because it's like an arrow. And the light sensors record it. They catch a neutrino and they see from where it's coming.
Particles produce an explosion of light, and an ice cube captures it in its sensors. What's critical in the design is how far light travels through the ice. The light sensors have to be spaced according to the absorption length, the average distance light travels in the ice. In tap water, light will travel.
Light travels in water 2 meters, tap water.
2 meters. In distilled water, 8 meters.
In distilled water, light goes 8 meters.
In ice beneath the South Pole, light travels more than 100 meters.
In the South Pole, it travels 100 meters because the ice in the South Pole is very clear. Because this they make their experiment day, so that when a small light there is, they detect it.
In some places, even more than 200 meters. The ice in the South Pole is one of the clearest solids that exists. It may not be possible to build a solid in a laboratory as transparent as this ultra-pure ice, which, in the end, is just snow that condensed and fell on Antarctica about 100,000 years ago at the depth of Ice Cube.
About 2 years ago, we were doing an analysis where we were looking for extremely high energy neutrinos.
They were looking for neutrinos. They look in particles so small, 1, 2, 5. They make this all the software just to detect a small particle. They catch it.
Exactly what we are looking for. We were looking for something that's called cosmogenic neutrinos. It doesn't matter what that is. We didn't find any. But when we looked at the data, we found something that we had never seen before. I remember when I was...
They catch a neutrino, it's not coming from the sun, because from the Cherenkov light, from the stars, from angels coming from another galaxies.
Show these events the first time. And over the years we have looked at thousands and thousands of events on the online display, and I knew I'd never seen events like those too. In fact, they were so special we called them birth and earth. After seeing them, it was clear what was special about these events, and we designed a new analysis that could go and look for more of these. So by now, Birth and Erwin has 26 more friends.
They catch 26 particles.
Published, claiming that we have evidence for neutrinos that come from space. Where do they come from? That's our next frontier. And of course, everybody has already ideas. We know that some of them are not emitted in the direction of the center or the plane of our own.
Some neutrinos are not coming from the sun, from other solar systems, from supernovas. The space is filled with neutrinos. They're searching this from where came, this from where came, they're searching.
The galaxy. So they come from outside the galaxy. There are hints in the data that some of them actually may come from our own galaxy. The problem is there is not enough statistics, there are not enough events to come to a conclusion. So then we started busy approaching a different direction. We started to look for more events. And so I think, I'm afraid you will have to stay tuned. But
okay. Now we have spoke about the neutrinos. We will speak something more smaller. Look, and you will see the angels surrounding the throne, exalting God and praise their Lord. In the resurrection day, they will see the angels. Now we don't see I think, it's my claim, our mind will be more sensitive to catch that light and see it and understand its coding system. I claim like this. We are finished from neutrinos. We will speak about something more small, smaller, more smaller.
Mysterious matter that scientists have never seen, but that plays a crucial role in the formation of planets, solar systems,
Now we will speak about spirits.
and galaxies.
Astronomers know that there's all sorts of matter out there that exerts a gravitational influence but that we can't see. We call that dark matter.
I wouldn't exist if they weren't for dark matter, because dark matter has this nurturing force of bringing things together to form structure, to form galaxies, which are absolutely necessary for life.
Dark matter makes up a staggering 85% of the gravitationally attractive stuff in the universe.
The universe is filled with neutrinos. There is about 85% of the universe is dark matter. And nobody knows what is it. We will search this.
If the dark matter is some kind of particle, then typically millions of dark matter particles will pass through me every second.
There is millions also dark matter particles passing. They didn't catch this. The neutrino, they catch it. But they know there is dark matter, but they didn't catch it. We will watch now how they know there is this substance, but they cannot catch it. We claim that these are spirits.
But even though they know dark matter exists, astronomers have been confounded by a microscopic mystery.
What? It has to be some sort of weird subatomic particle left over from the Big Bang when the universe was very hot and dense. A whole zoo of particles was created. Most of them annihilated or decayed into other particles, but some were left over, and they are what are thought to be the dark matter.
But what could this exotic microscopic particle be?
To detect WIMPs directly, if they're the right answer.
This is it, guys. Galaxy, there is invisible force around the galaxy. This is the dark matter. If there isn't the dark matter, nothing can exist. Because the dark energy matter, this nurses the galaxy. I will show you now, I will prove it to you, that there is dark matter.
Scientists find evidence of dark matter. Will they also find evidence of another world of dark planets? Dark life forms.
Okay, now we will show what proof we have of dark matter. We spoke about neutrino. It has a coding system and we catch it, because dark matter, the particles so small they haven't catch it. But how they know it's there? We will watch this now.
When we calculated why the universe is structured the way it is, it quickly became clear that there's just not enough normal matter. The gravity of the visible matter is not strong enough to form galaxies and complex.
Look what happened. This is the galaxy. The gravity of the galaxy, it's not enough to hold the stars. Okay? Because if it's holding by gravity, the stars must go out of the galaxy. But it's not going out. It's inside the galaxy.
The stars would more likely be scattered.
If it's holding by gravity, the stars must scatter. It's not scattering because there is dark matter manipulating and nursing the galaxies. It's taking care of them. This is spirit, I think.
All over the place and not form galaxies. So we know there is something else inside and around them. Something that doesn't emit or reflect light. Something dark. But besides being able to calculate the existence of dark matter, we can see it, kind of. Places with a high concentration of dark matter bend light passing nearby. So we know.
There is another proof they know that there is dark matter. how they see the galaxies far, because if there is here galaxy and here galaxy and we are here, how this we see the galaxy behind this one? Because when the light comes, it bends and it comes to us. Where there is dark matter, light bends. Because of this, they know there is dark matter.
There's something there that interacts with gravity that doesn't interact with light and matter in a way we expect. But right now, we just don't know. Dark energy is even more strange and mysterious.
There is more mysterious things also than the spirits. There is dark energy. I will tell you, Mr. Abedis, who are they? They are holders of the throne of God.
Yes, we can't detect it, we can't measure it, and we can't taste it. But we do see its effects very clearly. In 1929, Edwin Hubble examined how the wavelength of light emitted by distant galaxies shifts towards the red end of the electromagnetic spectrum as it travels through space. He found that fainter, more distant galaxies showed a large degree of redshift. Closer galaxies, not so much. Hubble determined that this was because the universe itself...
How they detect there is... We spoke about dark energy, they are the spirits, and dark matter is the spirits. Dark energy is the holder of the thrones. How we know about this? Because the light coming from the galaxy, it's bending. The light waves are bending because the universe is expanding, and it's expanding the light, it becomes redder. Because of this, they know the galaxies are going away. Because the way of the light is expanding and it's becoming red. If it's coming to them, it's become blue. If it's going, then it becomes red.
Is expanding.
It's stretching.
Occurs because the wavelengths of light are stretched as the universe expands. More recent discoveries have shown that the expansion of the universe is accelerating. Before that, it was thought that the pull of gravity would cause the expansion to either
If it's expanding, it becomes reddish. If it's just close, it's bluish.
Space doesn't change its properties as it expands. There's just
the force that expanding it, we claim that it's the فوقهم ثمانية يحملون عرش ربك.
More of it. New space is constantly created everywhere. Galaxy added to the confusion. Another idea is that empty space is
Look, even the holders are twins. They are pairs, but it's a claim, it's not true.
Full of temporary, virtual particles that spontaneously and continually form from nothing and then disappear into nothing again. The energy from those particles could be...
Okay.